Hi all, in this video we will be going over Newton's laws and free body diagrams. So the first thing we'll do is go over Newton's laws. So the first law is that objects move with a constant velocity unless acted on by a net external force. So what one needs to remember is that a velocity has magnitude and direction. So what it means is the size of the velocity vector and its direction will never change unless acted on by a net external force. The second of Newton's laws is the net force on an object is equal to its mass multiplied by the object's acceleration. So dF net is equal to the mass of the object times its acceleration. A more conceptual idea is that a net force causes an acceleration on an object. So the acceleration of an object will be equal to 1 over the mass times the net force. And sometimes you see the net force as being written as the sum of all the forces acting on the object, because that's what the net force is. And the third of Newton's laws is that in an interaction, forces come in pairs of equal magnitude but opposite directions. So what this says, there's two objects, A and B. Force on B due to A is equal to minus the force from B on A. Alright, now what we'll do is do an example problem that will teach us how to do free body diagrams. So in the problem, we're going to have a bucket with a person inside being raised at a constant rate of 5 meters per second. The weight of the bucket is 50 newtons and the weight of the person is 750 newtons. Now what we need to do is determine the tension in the rope. So what we can do is we can draw a little sketch, which I always recommend you doing, is drawing a sketch. This is the bucket, this is the rope being pulled up at a rate of 5 meters per second, and then there's a person in here. It's hanging out. It's a big bucket. So now what we need to do is figure out the tension in the rope. So I'm going to choose to draw a free body diagram of the bucket. So in a free body diagram, what you do is you treat the object as a point mass. So you draw a dot, and that's going to represent the bucket. And free body diagram means that it is free of the environment. So you don't draw anything else that's touching it, you only draw forces acting on it. So we're going to have tension in the rope. Sorry about that. Should go straight up. Tension in the rope. Acting upwards. We're going to have the weight of the bucket. Or let's see, this will be the weight of the person. And we can also have weight of the bucket here. So what you need to do is you need to draw the forces acting on it and labeling them. The next thing we need to do is we need to draw or write down our acceleration. So we need to define what way the acceleration is going. And at this point we need to realize Newton's first law. So Newton's first law says that if an object moves at a constant velocity, then there is no net external force. And the reverse is also true. So this is moving at a constant velocity, so there is no net external force. These do have a mass, so the acceleration has to be 0. So we write A is 0. Now we need to arbitrarily choose which way is positive. So we're going to take the positive x direction, so x positive, as upwards. So if you're pointing upwards, you're positive, and if you're pointing downwards, you're negative. So from here, we now go on to Newton's second law, where we sum the forces. So we look at this diagram, and T is pointing upwards, so it's positive. WP is pointing downwards, so it's negative. WB is pointing downwards, so it's also negative. and we set the equal to the net force, which is 0. Now we solve for tension, so we take WP and WB to the other side. We get WP plus WB, and that's going to be equal to 750 newtons plus 50 newtons equals 800 newtons. Alright, and that's everything for this. Thank you very much.